All right, let's talk about code communication. You know, we spend all this time building these perfect little objects, but how often do we really think about how they talk to each other? Because when that communication goes wrong, everything gets brittle fast. Today, we're going to dive into a really powerful solution, the elegant rules of engagement we call behavioral design patterns. You've been there, right? You open up a project and it's just this web of dependencies. Object A is calling B, which is calling C, which somehow loops back and calls A again. It's just chaotic. It's a total nightmare to debug, and you can't change one little thing without breaking something else. That, my friends, is the classic spaghetti code problem. So this tangled mess, it really points to a deeper issue in software design, and that's tightly coupled code. It's when your objects are just way too dependent on each other. They know all the intimate details of how the others work. And when that happens, your whole application just loses its flexibility. It becomes stiff, brittle, and just hates change.
This quote just nails a fear that every single developer understands. It's that feeling, right? You make what you think is a tiny, harmless change to fix a bug, and boom, suddenly 3 other, totally unrelated features are broken. That catastrophic cascade, it's not just bad luck. It's a direct symptom of bad communication design in your code.
So what's the fix? I mean, we can't just tell our objects to stop talking. Communication is absolutely essential. What we need are clear, structured rules for that communication. You know, a proper set of guidelines. And that is exactly the role of behavioral design patterns. Now, it's super important to get this. These patterns aren't about the structure of your objects themselves. No, they're all about the choreography of how they interact. Think of them like time-tested blueprints for managing these complex conversations, letting your objects work together effectively without getting all tangled up.
I love this analogy because it's just so perfect, right? Picture a chaotic room where everyone is just shouting over each other. It's a mess. Now picture an orderly debate with clear rules. That's the difference. These patterns bring that exact kind of social etiquette to your code, making sure all the conversations are polite, efficient, and, actually productive.
Okay, let's get practical. Let's look at our first example. This one tackles a really common problem. A request comes in, but who's supposed to handle it? Especially when the thing that sent the request has no clue who should. This whole idea is behind what we call the chain of responsibility. So imagine you've got a user action, maybe clicking a button. Now, lots of different things might be able to handle that click. The button itself, the panel it's in, the main window, who gets to process it. If you hard code the button to talk to just one specific handler, your code becomes super inflexible. The solution here is so elegant. Instead of one object having to know about all the possible handlers, you just create a chain of them. The request gets passed from one to the next, right down the line, until one of them says, "Yep, I got this," and processes it. The original sender is completely decoupled. It only cares that the request gets handled, not who does it. Honestly, think of it just like a relay race. The request is the baton. It enters the chain. The first handler, the first runner, looks at it and decides, is this my leg of the race? If it is, they take it, they process it, and the race is over for that baton. If not, they just pass it to the next handler in line. It's this simple, clean handoff that lets everyone focus on their own job.
All right, next up, a totally different kind of communication challenge. This time, it's not about finding one specific handler for a request. It's about broadcasting news to anyone and everyone who might need to know about it.
Think about a spreadsheet. When you change the value in just one cell, right? A bunch of charts, some graphs, maybe other cells with formulas, they all might need to update themselves. So how do you manage that without making that one little cell have a hard-coded list of every single thing that depends on it?
And this is where the observer pattern totally saves the day. It sets up this really simple publisher and subscriber relationship. The object whose state is changing, that's our publisher. And all the other objects that care about that state, well, they're the subscribers. The publisher basically becomes a town crier. It just keeps a list of its subscribers, all the villagers who've gathered in the square to listen. When something important happens, the crier just shouts out the news. And here's the key. They don't need to know each villager by name. New people can join the crowd, others can leave, and the crier never has to change what they're doing. It's that dynamic nature that makes this pattern so incredibly powerful. Okay, for our final pattern, let's talk about a situation where an object needs to do a job, but the exact way it does that job needs to be flexible. It needs to be able to change on the fly.
Let's use a navigation app as an example. Its main job is to calculate a route. But should it find the fastest route, the shortest one, or maybe the route that avoids all the tolls? The core task is the same, calculate a route, but the algorithm, the playbook it uses, needs to be swappable.
The strategy pattern has such a brilliant solution for this. You basically encapsulate each of those routing algorithms into its own little strategy object. Your main navigation object, what we call the context, doesn't actually do the calculation itself. Nope, it just holds a reference to one of these strategy objects and delegates the task to it.
So here's how that playbook works. First, you define a common interface that all your different strategies will follow. Then, you create a separate class for each one, like a fastest route strategy and a shortest route strategy. The main context object holds on to one of these. When it needs a route, it just says, hey, current strategy, do your thing. But the real magic is that you can swap that strategy at any time, completely changing the object's behavior without ever touching its own code.
Okay, so we've looked at 3 pretty cool patterns, but let's zoom out for a second. What's the big picture? Why should you really bother to learn and use these ideas in your own work?
Well, the payoff is huge. Your code becomes so much more flexible. You can swap behaviors and responsibilities super easily. You drastically reduce coupling, so your objects can talk to each other without being shackled together. This all leads to cleaner, more maintainable code, and it helps you avoid that catastrophic cascade we talked about at the beginning. Changes get isolated, which makes maintenance a predictable task instead of a total nightmare.
In the end, that's really what it's all about. Behavioral patterns are the tools we use to turn those chaotic shouting matches in our code into structured, elegant conversations. It's what separates a fragile, unpredictable system from a clean, maintainable, and truly professional one.
So as we wrap this up, I'll leave you with this question to chew on. Take a look at the project you're working on right now. Where are the communication bottlenecks? Where does the code feel tangled and brittle? Which conversation in your code could really use a new, more elegant set of rules?